Afternoon, guys. Are you all able to hear me okay? How about now? Is it any better now? Okay. Is everybody able to hear me okay?
Yes, sir.
Okay, great. So this week's tutorial, I will be discussing some of the draft projects you guys submitted over the weekend. I will just be talking about one today, just as an example. Before I start, I just want to say I am in no way picking on certain groups or singling out people. I'm just giving my constructive feedback and just demonstrating the type of feedback that I'll be providing for everybody. So please don't take it personally, like I'm attacking you or anything. It's just constructive criticism. I hope you take it that way. But before we start, I just want to talk to you guys a bit about Turnitin. So Turnitin is the plagiarism software that we use to check every submission to USP. So every Dropbox runs through Turnitin first, and Turnitin will then cross-check all of the whole project with outside sources, so internet sources, as well as internal sources. So sources already uploaded to USB database. It can even check across FNU, because FNU uses Turnitin as well. And any other university that uses Turnitin software, it'll cross-check all of its databases and then give you a percentage, which is basically the percentage that software believes you have plagiarized. So the acceptable limits that we have in USP are 0 to 20%, but for engineering, we go from 0 to 15%. So for this project, you have to have a plagiarism of less than 15. If you find yourself with a plagiarism over 15%, you will be receiving 0 mark and consequently failing this course. Now, don't worry too much about your draft report. There's still time to change. There's still time to make amendments and bring that score down. But just bear in mind that anything above 15% will be classified as plagiarized. Okay? And if you want to check exactly what it is that you've plagiarized, you can click on each one of these and it'll take you to a feedback studio, which is basically this. Okay, where it'll show you exactly what it is that you have plagiarized, or that it deems you have plagiarized. Sorry. Are you all aware of how Turnitin works and how you can check your plagiarism report? Okay, great. So for these guys, they got 1%. So it's very, very little plagiarized. So this is a very good report because it's saying that it's all their own words. Okay. Now we'll take a look at our example for today. So we are looking at the portable hydraulic press. Okay. Members, Sariana, Sristi, Vantika, Shivnit, and Yash. Please, when you submit your report, include the tutorial session that you belong to, because your tutors will be the ones who mark it. So I want to be able to tell which ones are mine easily without having to try and search IDs. So if you can just include the tutorial session that you belong to and highlight which one of these members is your group member. So just type GL next to your group member. I believe for this one, it was Shivneet, right? So these kind of comments are the ones that I'll do for everybody's report. I will hopefully try and finish it by the end of this weekend, send it back to you guys so you guys can have a look. And for my tutorial sessions exclusively, if you guys take the constructive criticism, you make some changes and you want to send it back to me to check again, I'll be happy to do that next week and the following week. Okay, is that clear? And I'll be checking everything that you've done up until evaluation. I won't check your designs or anything. I'll just check all the changes that I've already recommended. And if you've made them or you've made other changes that you want to show, you can do that. And I'll be happy to look at it next week or the following week. Okay, I thought for this group, the introduction was very good. They basically broke down everything that they did in this project and everything that we can expect to find detailed in this project. So they talked about the design process. They went from step to step and what they were required to do in each step. So I really like this introduction. Only thing is you may want to start with what the hydraulic press is. Just feed us a little bit of information, just a little paragraph talking about what the hydraulic press is and what it's generally used for. Bear in mind that as engineers, we're often communicating with people who aren't engineers. We're talking with investors, stakeholders, the general public. So they don't always have that technical knowledge or assume technical knowledge. So sometimes we have to give them a little bit of information before we start talking about giving them figures and so on and so forth. So that's just my little observation. You may want to talk a little bit about the hydraulic press in your introduction. For your analysis, you said, I'm not sure if you have to write something here. You don't have to write anything there. So for analysis, you can get rid of that. Because everybody to do analysis. Okay, how about now? Is it a bit clearer now? Okay. Sorry, the network keeps dropping in and out. So as I was saying, you don't have to include the analysis in your report. So removing analysis from your introduction is fine. So I like the way that you started your introduction. Problem statement, I thought was very good. It started with a very broad problem, and then it narrowed it down to the exact details of the problem. So I thought your problem statement was very well put together. So good job, guys. Design brief. This is fine for a design brief. I would count these as criteria. So hydraulic press will be made from materials which are locally available or available locally. May just want to mention why, just because it's cheaper, you know, just add a bit of justification as to why this is a criteria that you're interested in. Hydraulic press must be affordable. You've mentioned that in your problem statement that that's a big issue, so I agree. Hydraulic press must be durable, not corrode when exposed to bad weather conditions. Again, a very important criteria to have, so good addition. Must have good tensile strength. Now, I've talked about this in other tutorial sessions. It's all well and good when you include technical terms or engineering terms. You know, it adds a certain level of detail or you know, a degree of understanding. But make sure that your information is correct when you put it in, if you're going to use technical terms, okay? So a hydraulic press is primarily used to form pieces of sheet metal, if I'm correct, or you can form metal basically. Tensile strength is not necessarily a property you'd need. You'd need more compressive strength, because the actual ram is undergoing compressive forces, not tensile forces. So you may need to rewrite this as must have good compressive strength. Must be portable. Okay, you've mentioned this in your problem, so I 100% agree. Must be light and be able to exert at least 5 tons of force. Now, to this group, where did you get this value, 5 tons? Or why 5 tons? Is it because you found that in your research? Who's in this group? Sorry. Siriana? Any idea why? Or Sristi, any idea why you set the limit to 5 tons? Okay, if you got this number through your research, then I completely understand. But if this is just a fictitious number, you have to try and find some kind of way to build it into your design brief. It was a design goal to achieve 5 tons. Okay, but the design goal was set by who? Was it in the topic? Yes, it was from research. Okay, then I hope it's in your literature review that you said that 5 tons is like the threshold for portable hydraulic presses. If you're going to state it in your design brief, you need to have it somewhere in your research. It must have interchangeable parts, interchangeable plates to satisfy each user's requirement. This is a very good design criteria. Just a few things that you may want to look at. Background research. Now, a lot of people have started off their background research by talking about the history of the machine or the founder or when it was created. My question to you is that relevant to your design? Unless you're going to be using the same design concept as something that was designed in the 1700s, I don't see the importance of stating it in your background research. Okay, and the people who came up with it, again, it's not really. Okay, is that clear? Not everybody needs to do a origin or a background of whatever part that they're trying to design. Okay, only if it makes sense. And in this case, it doesn't really make sense. So I would get rid of this if I were you. Okay, functionality. This is very good paragraph, very informative. Make sure that you reference all of your information that you take from another source, okay? So I know certain bits in here that you used your research to then write. Make sure that you reference it. Uses of hydraulic press. This is very good. Materials for hydraulic press. Now, I wanted to ask you guys, are these materials that are already used in hydraulic press manufacture, or are these the materials that you have been looking at, or the materials that you're interested in using? Are these industry standard materials, carbon steel and stainless steel, or is it just the materials that you've researched? Okay, these are being used by industries. Okay, then you may want to include just a short description. And the materials for hydraulic use, you may want to say that it is industry standard to use, and then so and so, okay? Just state it that this is the industry standard, and this is the materials that we're going to be researching, and then later on you can make your inferences whether or not you want to use it. I like how you guys have got exact numbers and then you've referenced it, but this is not the proper form for referencing. I'm not sure if you're aware, but we're using IEEE referencing style. So if you were to reference, it would show up like this, and then you'd have your list of references at the end. Okay, I like how you've broken down each of the materials into their mechanical properties, and then identified the mechanical properties that you'll be interested in using. So you looked at carbon steel and stainless steel. Additional research. Just correct me if I'm wrong, but I get the sense that this is just a compilation of all the research that you've done. It's not a finalized literature review. Am I correct in assuming that? Is that a correct assumption to say that you guys haven't? Oh, okay. All right. Just some of your use of personal pronouns and things like that. Make sure that there are no personal pronouns in a technical report. And this goes for everybody, okay? Try and stay away from using personal pronouns as much as possible. You've also included a bit of an article. You need to properly read this, digest this, and then reword it. Because as it is, this is bringing your plagiarism count way up. And again, like I've said for a lot of the projects that I've reviewed so far, never underestimate the value of a picture to help deliver your information. Okay. Too many people get caught up on using big sentences and big paragraphs, big words, trying to sound technical, and you lose sight of what you're actually trying to get across, you know, the point that you're trying to get across. I've seen it a lot in a lot of projects so far, where people would rather write a 200-word paragraph when they could have easily just put a picture, a figure number, a caption, and had done with it, okay? Because a picture tells 1,000 words. I know it's an overused saying, but it's true. So wherever possible, guys, use pictures. Make sure that you reference those pictures if you take them from an online source. Because at the end of the day, your client is a human, and sometimes they don't want to read a 30-page report full of words. They'd rather look at a few pictures, get the general idea of what you're trying to talk about, get the technical details down, straight to the point, and be done with it, okay? So while I appreciate the amount of work that you guys have done, and I wouldn't cut any of this out, just include some pictures here and there. That's my main comment for your literature review. Those researches are just a compilation of the information to use later. Okay, that's fine. That's fine. I just wanted to clarify, just in case you guys forget later on to reword all of this. Design criteria. I think back in your design brief. Yes. So your design brief is just this. It's just a 1 or 2 sentences. Your design criteria is where you start listing all of the specific things that your design has to have. So design criteria, you can either put it before your literature review or you can put it after your literature review. Once you've done the research and you know exactly what you want to include in your design, you can put it then. So that's what these guys have decided to do. Must satisfy. This I found very interesting. If you guys can actually pull this off, I believe this will be a significant contribution to engineering as a whole. If you can pull off designing a hydraulic press to deliver 5 tons of compressive force for under $200. I'm I'm not sure I've ever heard anybody or anything capable of doing that. So $2,000, I understand. 200, oh, okay, $2,000. It should be 2,000. Okay, yeah, just materials used must be anti-corrosive. So it's not anti-corrosive. It's corrosion resistant. That's the mechanical property. Corrosion resistance, not anti-corrosion. And the exterior must be able to withstand environmental damage. Fair enough. Structure of the hydraulic press must be able to withstand 6 tons of force by the hydraulic. Okay, so are you saying that it should be able to withstand 6 tons, but it'll be expected to work with 5 tons? I'm a bit confused there. Because if it's delivering 5 tons of compressive force, it'll be experiencing 5 tons of force in the structure. Okay. So if you're going to be talking about 5 tons, it should be able to withstand 5 tons. Or you could say that you're working with a factor of safety, so it should be able to withstand 6 tons. But then you have to state to account for a factor of safety. Okay. You have to state why you're saying more than you're actually delivering. The hydraulic press must be able to be dismantled and stored in a 1 by 0.5 by 0.5 meter box container. These specific requirements, are these part of your problem? Your problem, you mentioned builders at work sites having to move around. Is it because they only have this much space, this much volume to transport their press in their vehicles? Is that why you've limited to this dimensions? Okay, so then you may want to mention that in your design problem statement that you know, the builders only have this much volume to work with, so we have to design it to be able to fit inside that volume, to be dismantled and fit inside that volume. The hydraulic press must be less than 30 kg. Again, 30 kg. Back this up with the research to show that 30 kg is even possible. Okay. Hydraulic press must be able to exert 5 tons of force. So I'm expecting that this weight criteria and this force criteria will be mentioned somewhere in your literature review. Okay. Possible solution and evaluation. I was very impressed with your drawings. They're very, very neat. Very well done. I just have just a query. Where are the actual hydraulic cylinders in these designs? Where does the hydraulic in the name hydraulic press come in? So I'm not too sure where the actual hydraulic ram is in all these designs. Maybe when you submit, you can try and get a bit of a clearer picture, because I can't really see this one. Okay, it's just a query. It's not a criticism. I'm just asking. And then you've gone into your decision matrix. Now your decision matrix has been done very well. I don't think you've done a weighted decision matrix. You've just done a decision matrix, which is fine. But I would like to see a degree of ranking the criteria in importance. Oh, criteria weight, is that done? So they're all equally important. Is that right? So they're all equally as important, equally important? Okay, from looking at your table, I'm assuming that they're all equally important. Oh, okay. So you're not actually designing the hydraulic ram itself, you're designing the stand that will hold the hydraulic ram. Oh, okay. Oh, okay. Right, then you may want to build that in somewhere, because all this time I was under the impression you guys were designing the hydraulic press, meaning all of its components. So you may want to build that into your problem statement, that you're actually just designing the stand to the stand for the hydraulic press, instead of actually designing the whole hydraulic press, including the hydraulics and the hydraulic cylinder and the ram and everything. Just a quick note on your evaluation. You have to try and justify each of these number scores that you give it, okay? So if you give it a 8 out of 10, why 8 out of 10 for possible solution 1? Why 8.5? Okay, you have to be very specific as to why you've given this score for this thing, okay? So you can say option 1 gets a score of 9.5 for portability because it blah, blah, blah. It'll be quite lengthy, but that is a proper evaluation. And you clearly justify the scores that you give, and then it adds a level of confidence when we say, okay, then you've really looked at all of these criteria, you've really analyzed all of these designs, and you really have chosen option 2 as the best one. If not, then we just take this as you guys filled out a table with a bunch of random numbers and just decided that you like option 2 the best. Okay. But all in all, I'm very impressed with this project. You guys have done a lot of good work. I applaud you guys for that. So thank you very much. I will be trying to upload a short tutorial video on how to use MS Word to do formatting, because I've seen a lot of people have issues with formatting. So hopefully by the end of the weekend, that tool will be up. But for now, thank you very much, guys, for attending this session. If you can please just leave your ID numbers in the chat so that I can take your attendance. And if you have any questions, please just let me know. Okay, guys, thank you very much. Have a good weekend.